Okay, now come to our AWS. So now we are going to use this YAML file for cloud setup. So we are first search for cloud formation. We arrived on AWS cloud formation. So we first create stack for our workshop. So that stack, so basically that cloud formation will create your cloud resources for you. That will we are going to use for this workshop. So basically it will create IAM role, S3 bucket and notebook instances in SageMaker notebook. And let's see what YAML file is. So we can visualize this resources configuration in view in designers. So here we can see all the means resources that is created for us. Yeah. So here you can see this will create IAM roles, MLOps exercise repo that will clone to SageMaker code repository, and it will create MLOps repository inside code commit, and it will create MLOps code repo that will also clone to SageMaker code repository. It will create S3 bucket, and also it will create Mlops Iris ECR repository, and it will create lambda function stacks. So this is a design we can explore here, how they will connect it to each other. Now you can also convert into JSON format and YAML. We uploaded YAML, and you can also change to JSON. Okay, now come back to our cloud formation create a stack. So now we will create a stack. So we will name AI workshop. So we will name MLOps workshop. So we will select a group ID, and we will select subnet ID, and we will go next, next, and at the last we will check these two box, create a stack. Now the creation in a progress. It will create resources for you. This you can here you can see the information overview of this stack, and also you can check the events that are created for creating this stack. So here you can see they will creating this MLOps Iris repo. It is created, completed, and you can also see that we are seeing inside this uh, this YAML file. So here you can see this will create MLOps security, MLOps lambda layers. That is the logical ID inside this, right? So here you can see MLOps security, MLOps lambda layer. That is logical ID for here. And also you can go to resources and see the resources here is completed, and here they given a link. By clicking this, you can click on this link. You will redirected to this resource, build pipeline iris model. So you can click on it and you go to this nested stack. Yeah. So this MLOps workshop we created using a ml.yaml file, and all of this nested stack is created internally. So one stack for MLOps security, MLOps lambda layer, deployment operator, MLOps training, MLOps process request. This is created inside this YAML file. So you can see here. So basically we are using this AWS CloudFormation stack. So this all these are created inside CloudFormation. So we they will mention here like a nested stack. So here you have to remember here first you did if you want to delete resources from here, so you first only delete this MLOps workshop stack, and all the nested stack will delete it automatically. So you for remember this, if you deleted this nested first, so you have come into some problem, the some resources will give you error on the deleting time. So you have to remember it. Now we have created all the resources. Now we can go to and check one by one. So we will check build a pipeline iris model. So this is the idea, and you can check. Yeah, so here you can see the code build project is created, code pipeline is created for deployment MLOps iris model. Okay, so now our cloud setup is completed. Now go to now go to SageMaker. And go to notebook instance. Now here you can see this instance is created, and status is pending. Now its instance is going to up, so it's in a pending state. So we have to wait for 2-3 minutes here. Once is up, then we'll go to no Jupyter Lab, where we get all the repository we assign. So basically in Git repository you have these two repos that we are talking about, right? MLOps code repo, MLOps exercise repo. These two repo we are using inside this notebook instance, right? So here you have remember the name MLOps code repo. So this will be so this will be this MLOps exercise repo, MLOps code repo, right? This we are attached here in SageMaker Git repositories. So these two repository we are using inside this notebook. So we are going to click on open Jupyter Lab. This will redirect to Jupyter Lab. Yeah, so we have these two repository inside this instance. So we have SageMaker, Amazon SageMaker workshop. Here we have labs. Inside this lab we have step-by-step notebook that we are going to run. So we first go to this lab, and we are going to start with 01 create algorithm container. This will create so we using percent write file trend.py. So basically whatever inside this cell, it will create a .py file and write this code inside this trend.py file. So we will run this, and here you can see trend.py file is created. Now you can check here the all the code inside this cell is written to this file. And now we will so basically the first part is creating the assets required to build test Docker image. So we are creating asset that we going to build this Docker image, and we will going to test this Docker image with our data. Okay, so training file is created, handler file is also created, and main file from the all this is a main file, the entry point for our container. So we created now we create a Docker file. So here you can see we created a Docker file. So you can check the documentation how we can create a Docker file. So this is the step we are created using this. So basically we are copying all the code inside this optml code directly inside this Docker. So we will copy paste it inside this, and the entry point of this Docker is to run this main file. And now finally the build spec is created for code build. So this file will be used by code build for creating our container image. With this file, code will run the docker build command. So this build spec will be run a docker build command using the asset we created above. This is our assets: handler.py, main.py, trend.py. Deploy the image to the registry. So after creating a docker image, this will deploy this created docker image to ECR repository. So here we have a phases here: install docker version 18, and second phase is pre-build. So pre-build we have authenticating this we providing credential to connect this ECR, and third is build. So here build command for Docker. So we are building a Docker image, right? And at the last we post, after building Docker image, we are pushing this Docker image to ECR repository. So ECR repository is Elastic Container Registry. So we will push this Docker image to ECR. Now we have to run this. Now we run, and now we local test. Let's build the image locally and do some test. We are building this Docker image here, so it will build your Docker image here. It will take time. Yeah, now yeah, it's running. Okay, now after build so basically the image name is iris model, and the tag is 1.0. So this is our image name. And the second step is we are testing this Docker image. That is our custom algorithm Docker image. So we are run it to train and deploy a model. So basically we first preparing a data set. is still running. So it basically setting up the environment for running training and deployment. So all the dependencies are installed inside this Docker image. Once it's completed, now we are going to prepare our dataset for testing this Docker image. Yeah, so Docker image is built successfully, and now we have to test this Docker image, and now we preparing our dataset for training. It's running. Yeah, so it's created a input folder, and inside this we have data for training and validation. Now we are just a basic local test using a Docker, local Docker, and we are configuring hyperparameters, resource config, and input data configs, and under this last cell we are running this Docker image for training purpose. So it will train your model. So this basically printing the data inside this training and testing CSV. And now this training is completed. So we actually uses yeah, this is a very small data set for only testing purpose. So now next step is our model is trained. Now it's time to serve this now to test this model by creating a server. So this is the serving test. It will simulate an endpoint exposed by SageMaker. So basically it will create a endpoint for you, so you can send data, and it will send you back send the prediction back to you. Now first create the server. So now our server is up. Now this is a test notebook, so we are going to open this notebook and run this, and response code is 200, so the connection is successful. Now we have to run this test. Now yes, now we get the predictions here. So we get the response from the server. So here is the prediction. You can see prediction 0, 2, 1. Yeah, so it successfully tested our. Now we have to stop this server, so we click on here, so interrupt the cell. So we interrupted successfully. Now it's time to integrate a test. Everything seems okay. Now it's time to put all together. So we will start by running a local build code build test to check the build spec, and also deploy this image into a container registry. And we will locally running code build test, and testing for only build spec testing purpose, and we will deploy this Docker image to container registry, that is ECR. So the so we will see, so repo name is inside ECR is iris underscore model. It is already created there when we are creating a cloud setup using CloudFormation. This is all set by that cloud formation. Repo name equal to iris model, and image tag is test, right? So we will push this image we tagged as test. Okay, now we are running and getting the some account ID, region and credentials. Now we are creating a test folder. Inside this we are creating a vars.env file where we stored all these parameters, environment parameter that we are going to use inside this. So we leave this cell, so basically it is not required here. Yeah, so we are going to run this. So this is cell we building our docker image locally for testing purpose, and we will pushing to our docker ECR repository. Okay, now it will take time. Yeah, so it created our docker image here first locally. This is docker build command, and this created first locally, and then this will pushing this docker image to this uh, this repository iris model, and yes, and it still running. When post is successful, then we'll test this image. It's taking time. Now the docker image pushed to ECR. So this is succeed message. All of this step is performing in a build pipeline. So this is a local build test, and this build we will automate this through code pipeline. Okay, so now it's time to test this ECR image using this. So we will set up for test. So we are using this default SageMaker bucket. So this is a default SageMaker. It is created automatically for you, and now we upload our dataset to this default bucket. Now it's uploaded. Now we will set all the parameters and hyperparameter for training. Yeah, now we will fit the data. It will train your model. Now training job is completed, so it basically a small data. So it's time to deploy our model locally and test. So it's deployed. Now we have to test with this deployed model. So basically we get the result here. This is false. Now we have to delete this endpoint. Okay, now we completed this test also with ECR repo. Now fourth part is let's push all the assets to the Git repo connected to the build pipeline. That pipeline will docker images automatically when this assets that build spec.ml, handler.py, trend.py, and main.py and docker file push to this repository mlops. So when the new changes come to this repository, it will automatically trigger this build pipeline. So it's time to push all the asset to our mlops code commit repository. So so all the files are pushed to our code commit repository. Now step is to go to code pipeline dashboard, check the model iris model, mlops iris model. Okay, and then deploy the final image to ECR repo. Let's check the process. Go to code pipeline. Yes, so mlops iris model is in progress. This is automated pipeline for building a docker image that is already created by our cloud formation and in a nested so this is our build pipeline. This is created by this stack mlops workshop build pipeline iris model. So now come to this part, and we get the code commit resource. Now it is build process in progress, so we can check the logs here. We can check here. So it will building a docker image. So it will take about 3 minutes to complete this build process. So now it pushing this iris image to our ECR image repository, that is iris model, and it will tag this image as latest. So this process is succeeded successfully. So here we get the succeed state here, and it will show the build status is succeeded here, and it completed here, right? So this is pipeline is running fine. Yeah, so this is a build project that is created by cloud formation automatically. So you can check out the all YAML files that inside in m.yaml. So this is pipeline succeeded. Now come to automated training and deployment pipeline, right? That is iris model pipeline. So this is created already here. So it in a S3 bucket they did not get the assets and the data set. That's why it's in a failed status. So now go back to SageMaker, Jupyter Lab, and close all the file and go to lab and run this train your model second part, that is will create the configuration for training. So basically now it time to for start an automated ML pipeline using the MLOps environment. So we will do that by putting a zip file called training job.zip in a S3 bucket. Code pipeline will listen to that bucket and start a job. This zip file has the following structure: training job.json. This is a SageMaker training job descriptor. Here in this JSON file, the training configuration is for SageMaker, only for SageMaker training. And environment.json instruction to the environment how to deploy and prepare the endpoint. So basically JSON environment JSON file is configuration for deployment and prepare for how to prepare endpoint for inference. So now we first in a previous section we run this 01 underscore create algorithm container. So we already run that. And so basically we have to, if you previously run that, so you have to use exiboost bulletin equal to false. So we already done that. So we are using this custom container image. Yeah, so we are going, in this section will run. So we are using a custom ECR Docker image. Sorry. So our image is iris model tag with latest. So we are run this file, run this cell. So this is our Docker image here. So we are going to use this Docker image, and the hyperparameters are this: max depth 11 and job 5 and estimator equal to 120. Now this will create a training job descriptor. So for only for that is used inside SageMaker training, right? So here you can see the training trend model will be stored in SageMaker default. So basically training parameter will be stored in as default S3 bucket, and we are using ml.m4x large instance for training, and volume size is 30 GB, and job name. So all this parameter we are setting for our training. So this is a training data set. The S3 bucket which is stored this training data set, that is a default S3 bucket, and similarly to validation, right? So this will run, and deployment parameters. So we will define endpoint prefix, deployment endpoint, and this will inference output bucket and samples that we are using to going to send this endpoint. So we are using ml.t2 large for inference, for inference, right? So we are assigning auto scaling. It will auto scaling equal to none, right? For deployment endpoint, at the production endpoint we are using instance type is ml.c5.large. See, it is CPU optimized. So you can see the AWS instance type. You can where you can check the all the instances and their configurations. Okay, now we are defining auto scaling capacity. It's so max, min and target value, scale in cooldown, out cooldown. This all the we are defining for auto scaling this production endpoint. Okay, now run this. Now we define all configuration for training and deployment. So in a deployment we define two configuration for deployment endpoint and production endpoint. At the last, now it's time to start a training job though. So basically all the configuration we have, this is pushes to our Mlops bucket, and this is a key name for the inside this bucket. This is a training underscore job, and that is a model prefix, and this zip file is stored in this folders, and these two files are zipped under this zip file. So basically this will put inside this Mlops bucket. You can check, we will check where this is stored. Now run, and it will push this configuration to S3 bucket. Now we have to check that S3 bucket. So this is our Mlops bucket. So here you can see training underscore job folder is created. The model prefix is and iris and hyphen model, and that file is stored here. Okay, now it's time to go to our pipeline. Actually we pushed that zip file to our S3 bucket. That S3 bucket is connected to this iris model pipeline that will listen to this S3 bucket. If there is any like any new job configuration is pushes to that S3 bucket, and it will automatically initialize this pipeline. So it is so source action is succeed, and process request is in progress. So it will running step by step these actions. So it will process your zip file, and it will process and extract the information for deployment, training, and it will extract the information training, and for deployment. In deployment there is a two-way deployment, is one for development and second is for production. So it will process successfully. Now we come to this training. So basically training in progress. Now we can check inside CloudFormation. It will create a new stack. So it created a new stack here. This is MLOps training iris model job. Right here we can check the events, right? So it will take time about 6 minutes to complete the training. So yeah, training is completed successfully. So now it going to deploy this train model into development environment. So it is in progress. So we can check out the CloudFormation stack. It will created a new stack for deployment purpose. So the deployment in a development environment. So we can check the events here. So it is in currently progress. So we can check this endpoint. So basically it deploy this endpoint to SageMaker endpoint. So we can check there. So we go to SageMaker. This is SageMaker, and go to training. So here you can check the training job. That is yeah. So today we performed here. So this is a training job that we performed today. Yeah, and now you can check the endpoint here. So this is status in creating. So it will created this iris model development endpoint, right? So it is in a progress. When this status is in service, then in deployment of this endpoint is in service. So it will take time. Yeah, yes, the deployment part is now completed. I think so. It's still in progress. So in a SageMaker it is in service status. So I think it is deployed. Now go to pipeline and it's taking time. Yeah, that development deployment is successful. So it is in service. So you can check out into Amazon SageMaker at in France in endpoints. Okay, now it is waiting for deploy approval for production. So here we can review this. Before this we have to go to lab and run this notebook, and we will going to run all of this cell. So basically this cell only used for, so here we are giving the access and a description above approve. So it is now approved. So here we can also approve this, but we are going to approve this process from here. So we are running this and it is still in running. Let's check the, yeah, so we have to approve this. Now it is approved. Right, and it will go to deployment in a production environment. Yes, and we can test our model. So it will give you the prediction of only deployment. So basically development deployment is successful, and the production deployment is in progress. So it will give you only production deployment prediction only. So it will give the PR production inference some errors. So it is basically not founding endpoint. Okay, so here now, so it will take around something 14 minutes. Now deployment in production is succeeded successfully. So we can also check out in this Amazon SageMaker endpoints. So we have two endpoints, one for production and one for development. So this two endpoint where our iris model is deployed. So now come to our Jupyter lab. Now we are testing our models. So yeah, so we successfully get the inference from a deployment endpoint and a production endpoint, right? So And this is complete tutorial for end-to-end pipeline for machine learning MLOps. So basically we developed a Docker image for our custom image. That image we are using for our training and deployment purpose. So we created endpoint, and we in using that endpoint we send it this payload, and we get the inference, right? Okay, now so this is complete. We completed here. So this is a pipeline end. So this pipeline is automated now. So we tested all the actions of the pipeline. Now this source is now connected to our S3 bucket. This bucket will listen. So this pipeline listen to this S3 bucket. So we can check here which bucket we are using here. So we can click on it, and this is the job we are using, right? So when this file is changed, this will trigger. So this is actually versioning 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 bucket. Okay, yeah, fine. So we completed this tutorial here. Now come to destroy all the resources we are created, right? So if you did not destroy all the resources, this will means charge some bucks, right, in a dollar, like $10 per day. So you make sure you have deleted all the stacks that created by this pipeline or this MLOps workshop. So make sure you first delete these three individual stacks. So first delete MLOps deploy iris model production. Click on it and delete stack, and delete the second one. So basically this is in progress. Please do not delete this nested and MLOps workshop. So it is in progress. Once it deleted, now delete the second stack and delete the third one. So it will destroy all the endpoints for production and development. Once it complete, then we'll go to destroy this MLOps workshop. The nested stack is automatically deleted. So it is basically created by this MLOps workshop. So we only need to delete this MLOps workshop only. So it takes some time. Yeah, now that 3 stack is deleted successfully, and now it's time to delete that MLOps workshop. It will deleted all the resources that we created from that we created. So click on, and this will deleted all of these resources. So delete stack. So it deleting one by one. So now stack is deleted. So here we can see all the resource endpoints is deleted, and also we can check the notebook. Notebook is still in deleting process. So this will deleting. So we have to wait. And here all the pipelines are deleted successfully. And also we can check the repository also deleted here. Okay, let's see. Build project is deleted. You have to wait until this will delete successfully. Now here you can check all the stacks are deleted successfully, and and now this is the end of the tutorial. So we successfully created two pipeline for building Docker image and one for automated training and deployment. Okay, hope you like this session. So it is a complete hands-on MLOps workshop that we created a model for Iris model. Okay, thank you guys.